So some quadratic equations can be solved by factoring. I can't read this, but most quadratic equations, well, not most. If it's solved, it can be solved using the quadratic formula. Okay, now I would use factoring as a first approach, right? Because if it factors, yeah, that's pretty easy to do. It doesn't take a lot of time. Quadratic formula is a little more involved, but the steps are there. It's really just a matter of getting it written in the proper form, identifying the values, and away you go. So first we need to review some radical skills. So we need to change entire radicals to mixed radicals, because once we get an answer, there will be a radical in that answer, and we need to maybe change its form. So root 40, what do we do with that? So you think about how do I change an entire radical to a mixed radical, and you think about, did we ever do that? Yeah, it was in 10C. Okay, so there are some, I've got some videos up on that on my YouTube channel if you're interested, or just go to Khan Academy, changing entire radicals to mixed radicals. Just you need a quick review, right? And I think Khan Academy is good because videos are usually only about 5 or 8 minutes long, right? It's just quick, pop in there, type in, entire radicals or something, find the video on changing an entire to a mix, get a little bit of review. But what we look for is I want a perfect square that goes into 40. So perfect squares, 2 squared is 4, 3 squared is 9. So perfect squares are 4, 9, 16, 25, etc. So what goes into 40 that's a perfect square? 4. So what we then do is we write it as, so we split 40 up into a product, right? I'm going to write it as 4 times 10, where one of the factors, in essence, I'm kind of factoring the 40, right? One of the factors has to be a perfect square, in this case 4. And then we split that out, and we can now write, so it becomes the radical of a product is the product of the 2 individual radicals. And what is the square root of 4? 2. So the entire radical is root 40, the mixed radical is 2 root 10. Okay, so when we solve using the quadratic formula, if we end up with a root 40, or root 200 or 18, any of these radicals, under the radical sign, we need to change them to a mixed radical because there may be one further step in simplifying the answer. Okay, so you'll have an answer, but we need to simplify. Okay, root 200 will be 100 times 2. So a little bit of space, which is equal to root 100 root 2, or 10 root 2. Now when you simplify radical, if you're wondering, did I do this right, just go in your calculator, type in root 200, hit enter. Type in 10 root 2, hit enter. What should you see? They should be the same, right? So if they're the same, then it's all good. Right? If they're not, then you made a mistake. And to make sure that you've got the lowest radical, always look at the number under the radical sign. Make sure there's no perfect square that goes into that. Right? Because sometimes, and here's the big key, if 4 goes into it, maybe 16 goes into it. Maybe 64 goes into it. Right? So that, not into 18 or 75, obviously, right? But 32, you just look at 32 and say 4 goes into that. And so wait a sec, 16 goes into it, right? So I want the largest perfect square. So root 18, what's the largest perfect square that goes into 18? 9. So we write it as 9 times 2, which is root 9 root 2, or 3 root 2. Okay, you want to give root 75 a try? So you do it the same way, right? You can write out all 3. You can just put the answer if you like. Like I look at root 75 and I just say, oh, it's blah. Actually, I say it's 5 root 3. So did you get 5 root 3? So it's the root of 25 times 3, root 25, root 3, 5 root 3. 150. What's the biggest square that goes into 150? Try it. So get your calculator out. No. 150 divided by 4. No. 150 divided by 9. No. 150 divided by 16. 150 divided by 15 is not a perfect square. Right? So remember, when we're going to write this as a product, I can write 150 as 15 times 10, but I can't do anything with that, right? Because there's no root 15. So 25, how many times does 25 go in? 6. So we go root, it's the root of 25 times 6, which is root 25 root 6, or 5 root 6. What's the square root of 81? 9. So here's what's going to happen. Sometimes, when you use the quadratic formula, you'll end up with a perfect square under the radical sign. And what that'll tell you when you go to work out the answers is, oh, this thing would have factored. Right? So if I get like a root 81, that's a 9, then the expression would have factored. Does it matter? No. Okay, like if we just say algebraically determine the roots of blah, doesn't matter how you do it, right? If you could do it by factoring, great. If you use the quadratic formula and then at that point you realize, oh, I would have factored. Doesn't matter. Okay, you've still solved it algebraically. If it says solve algebraically by factoring, then you must factor. But it will factor, right? We're not going to ask you to solve by factoring and it won't. But some of the ones that you will have to solve won't factor, and that's why we're doing quadratic formula. Okay, root 32 is 4 root 2, and this is 2 root 5. Okay, and do you all see how those came to be? How to get that? So it's fine if you just go from root 40 to 2 root 10, right? I don't need to see any work. It's also fine if you know, on the side of the paper, you just write down root 40 and do that whole thing there. Okay. You have to do what works for you. Okay. Questions on mixed, entire radicals to mixed? Next, simplify each of the following radical expressions. Approximate value to the nearest hundredth. So, sometimes when we use the quadratic formula to solve for something, we're looking for an answer to the nearest hundredth, right? I mean, maybe we need to, you know, put something around a window or something, and the expression we get, or the model, gives us a quadratic function, and we need to find the roots. But we say, you know, it's okay, I just need it to the nearest hundredth, right? You can't walk into Home Depot and say, I need 2 root 10 meters of whatever. What? So, what's the root of 70? Now, you can make life very easy on yourself if right now you just go into mode, float, and 2, right? Set it to 2 decimals, because that'll round to the hundredth for you. You can do that on a test, you can do that on an exam. Okay, so go mode, and then float. Move the float over to 2, hit enter, go second function, quit. What that'll do is just your calculator will now round everything to the nearest hundredth. 8.37. Okay, so how much? 8.37. The root of 123. 11.09. 11.09. The root of 310.
17.61.
17.61. The root of negative 40. What's it say?
Error.
Error. Not real answer. Get real. Okay, so you cannot take the square root of a negative, right? Now, sometimes we may get that. What's that going to tell us? If I'm trying to solve something and I get a negative under the radical sign, what does that say to me? You can't solve it. Now, to back that up, right? So you may get that. I would leave that question at that point if it were a test. I mean, if it's an assignment question, then I would investigate further. If it's a test question, I'd leave it. I'd come back to it later. I would try graphing it. Because what this is saying is there is no real roots. Or there are no real roots, right? And that means if you got a quadratic that opened up and whose vertex was above the axis, how many x-intercepts would you have? 0. That's what that root of negative 40 is telling, right? There are no roots. There's no solution. So, you know, if you get that while you're working it out, go finish the rest of the test, come back to that question, graph the thing, look at it, and say, oh, wait, there's 2 solutions here. I must have made a mistake. Okay. What we're going to be really dealing with is expressions that look like this, so let's get some practice in evaluating. So make sure you calculator out, do this. The square root of. Enter it exactly as you see it. Okay, I just want to make sure everybody's getting the same number. So what is it? 4.12. 4 point. Did everybody get 4.12? No. What'd you get?
4.12.
I have two 4.12s or multiple 4.12s. I'm gonna go with 4.12. Do the next one. Non-real answer. No real answer. Okay, this is what it's really going to look like, right? Like when we solve this thing. So work this one out. Everybody do it. If you're going to make mistakes, do it. If you're going to make a mistake, make them now. It's a low-cost error, right? There's no marks involved in this. Just a chance for you to get some feedback, right? Say, geez, maybe I'm entering something wrong. Or how can I make sure I get the right answer? Okay, so I want everybody to have an answer, and then we'll make sure you get the right answer. Unless you got the right answer. Okay, so. Yeah. The real answer.
Negative 3.7.
Negative 2.73?
3.7.
3.73? Maybe get something different? Okay. Hang on, I'm gonna pause. If I want to type this in exactly the way I see it, I have to add a couple of things, right? So this division bar here means you work out the top, you work out the bottom, and then you do the divide. Now we do that with brackets, right? So we say I'm going to put a bracket here and a bracket here, and when I divide, 2 times 1 is just 2, right? So. Okay, so I'm going to enter this, right? So I'm going to start off with the bracket. I'm going to go -2. This is the negative you use, right? That's -2, that's minus, which is now what I'm going to enter, minus the square root, so second function root. Whoops, didn't get the minus sign there. Minus, I got a pen mark. Minus the square root of, okay, so I've got 2 squared, bracket 2, bracket squared. Put those brackets in, right? Because when you have the negative, you need them. You don't need them with the positive, but if you're always in the habit of, I'm going to go bracket, number, bracket, you're always going to get it right. If you're not in that habit, when it's negatives, you'll get some of them wrong. Okay, anyway, so bracket 2, bracket squared, minus 4. When you see brackets, you can go times 1 times -2. Okay, I need to get out of the radical sign. I've now done my top, so I'm going to put a bracket in there. Right? So what I've said to the calculator is I want you to evaluate the entire top expression, right? And now I want you to divide that by, and I'm going to put a bracket down. I'm going to put 2 times 1, which is extraordinarily silly, right? Really, 2 times 1. But, and then I can close that off with another bracket. Notice how it becomes a really big bracket, and it just says this is closing off the entire expression, and I hit enter, and all right, I already did that bracket. Okay, so never mind. -2.73. Yeah. -2.73. Okay, I'm going to show you another way to do this, right? I mean, you should have some multiple strategies, right? So you pick the one that works for you. Here's a different way. It's really much the same. I'm just going to enter the top expression, right? So I'm going to go -2 minus the square root of bracket 2, bracket squared, minus 4. And if you want, you could just put brackets in. Bracket 1, bracket, bracket, -2, bracket. And I'm done, so I'm going to hit enter. So I've now worked out the square root. I've worked out the top, right? And then I'm going to divide that by the bottom. So I'm just going to go divided by 2 because I know that 2 times 1 is 2. On this one, I would just go divided by 4, right? So that way I don't have to worry about the extra set of brackets. I don't have to worry about bracketing the numerator and then putting the division in, I'm just gonna say, you know what, let's work out the numerator. And now I have a number. I want to divide that by, and the bottom number is always going to be an easy number, right? Divide that by, and then put that number in. Okay, do this one. Should be able to get that one right now. Is it really?
Yeah.
64 minus 48 is 16, that's 4. Yeah, 8 plus 2, that is, sure, it's 12. 64 minus 8, 48. 64 minus 48 is 16. The root of 16 is 4. 8 plus 4 is 12. Divided by 4 is 3. I think it's 3.
Oh, I went bracket.
Okay, so I'm going to go 8 plus, I'm going to work out the top, second function root. Bracket, negative 8, bracket, squared. Minus 4, bracket 6, bracket, bracket 2, bracket, I'm done that. Divided by 4 is 3.
That worked better in my head than you work on a calculator.
You get 3.
Yeah.
Good. Okay? So, look. Did I tell you the secret? One of the secrets. This is a different secret.
Mother's love.
Yeah. Some of you will never get that. But obviously you have that. So, you know, not to worry. So here's the secret in doing homework, be it math, science, anything, right? It's called fix it, focus, practice. Fix it. Put a dash in there if you like. Fix dash it. Fix it, focus, practice. Which means do a question, check the answer. Right? You can do 2 questions in a row, or 10 questions. You do 10 questions in a row, and you get them all wrong. You now know how to do that particular skill wrong very well, and it'll be very hard to break it. Okay? So fix it, focus, practice. What happens in every practice out there on the football field? Coaches are watching you. They're going to point out that you do the drill. You know, Ethan, you just did that wrong 10 times. You know? Yeah. They're not going to let you get away with a poor stance 10 times in a row. If they do, you're now locked into that. This is how your body feels. Right? They're going to fix it. So they're going to fix it, focus, practice, so that you are in the perfect stance every single time. Right? That's your body just knows. You just fall into it. You don't have to think about it. And same thing in math, right? Do a question, check the answer. If it's wrong, fix it. How do you fix it? Find out, right? Come and see me, ask somebody what you do, I didn't get the right answer here. Right? It might be stuff like working that out, getting the negative 2.73. That's what we want to do, right? We want to get the wrong answer so we can fix it. That's what practice is about. Why we practice? Practice is to fix those things so that we, you know, when the game time comes or the test time comes, then you know how to do it correctly. Okay, so fix it. That's math, science, English, whatever, right? I mean, you know, in English you write a draft of something, and then you go through it and you start to fix it. Right? Correct the spelling mistakes. I mean, this doesn't make any sense. Who wrote this? I mean, come on. The quadratic formula can be used to solve a quadratic equation in the standard form. Okay, so we should be used to getting stuff in this form, right? We want it to be equal to 0. Right? That's what quadratic equations are all about. Remember, first unit was quadratic function. The quadratic function is y equals ax squared plus bx plus c. Gives us a nice parabola, has an axis of symmetry in the middle. The vertex goes through the axis of symmetry. Use point P and Q or H and K, I never remember which, for the vertex. Right? And we get that axis of symmetry, even though the vertex. And we wanted to find a max or a min. We're solving problems where we want to maximize the profit. Right, you're in business. You know, hey, if I lower the price, then I'll get this many. So they lowered the price of football games to free this year. So yeah, but you don't have to pay to get into a high school football game anymore, right? So I don't know why. I guess they'll increase. You know, they're not going to increase profit. They probably decided we don't need to make any money off this or whatever. Anyways, so here's the quadratic formula. Pretty much going to see it like this. And the x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you sing it to the tune of Pop Goes the Weasel, you'll never forget it. But if I do, your ears will just hurt.
goes something like that. I should turn the volume in. You know, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Over 2a.
That's the quadratic formula. You still get 2a, you find better signal. You do not have to memorize it, okay? So, but you know, just think of pop goes to the weasel as you look at it. Okay? As a matter of fact, don't memorize it. I'm going to give you a formula sheet on test. Make sure you're just writing it down. Every single question you solve using that, I want to see it at the top. You come to me for help and it's quadratic formula. I don't see the formula, so go away. Okay? Seriously, go away. You look at everything I've done, every video I've ever done on solving quadratic formula, whatever grade, whenever I use it, I write it down. Okay? Anytime I use any formula, math 30-1, 30-2, 30, whatever, I always write down the formula, right? And then I substitute in, because I told you that secret to math, right? What? Formula, substitution, answer. Okay? So we now have the quadratic formula. There it is. We didn't even have to develop it. Solve the quadratic equation 2x squared minus 7x plus 5 equals 0 by factoring and using the quadratic formula. So just to show you, if it factors, you can factor it. We're going to factor this, we're getting an answer. Sometimes it does factor and you just don't see it, right? And don't waste 20 minutes. And you know, if we say solve by factoring and you can't factor it, there are other ways. But you should leave it and come back to it later. Remember the way I showed you graph it? From the graph you can find the roots. Okay? Or you can use the quadratic formula and you can find the roots. And then, but if it says solve by factoring and use the quadratic formula, that's how many marks you're going to get, right? None. 0, right? Because we want to see a specific method. Okay, anyways, factor this. Go ahead, should be able to factor it. Two numbers that multiply to 5, they're pretty easy to find. Only two numbers that multiply to 5. So I think I'm going to put the 1 there and the 5 there and toss in a couple minus signs. Okay. After you factor, what should you always do? Check it, right? So what do we got? 2x squared minus 2x minus 5x is minus 7x. That's good. Negative 5 times negative 1 is positive 5. That's good. Okay. So what is x? 5 over 2. Right, nice bracy brackets around there, right? Say it's a solution set. It's a set of numbers, 5 over 2 and 1. Okay, quadratic formula should give us the same answers, right? Otherwise, it's not really a very useful thing. Hey, I do it this way, I got one set of answers, I do it this way, I get everything. Okay, in this equation, what's A?
2.
What's B? Negative 7, right? And what's C?
9.
Okay, so let's substitute in. X is equal to negative 7. Plus or minus?
Doesn't matter what you do.
Me, I would write down 7.
No, for plus or minus.
But no, you have to write down both. Because there's two answers, right?
Oh, right.
So that's why it's a plus or minus. Okay, b squared. Remember we put the b in brackets. Squared minus 4, bracket, 2, bracket, bracket, 5, bracket. Extend the radical sign out so it goes over the whole thing. Bless you. Over 2 times a, which is 2, bracket, 2, bracket. Now, I can work that. Okay, so I'm going to work that down. So what's the negative of negative 7? 7. Positive 7. Are you sure? I'm positive. 7. What is negative 7 quantity squared? What do you get when you square? When you multiply negative 7 times negative 7? 49. Here's a hint. This will always be positive, right? Because you're squaring something. When you square something, it's always positive. So 49. Minus. Now there's no negatives here, right? So it's just 4 times 2 is, times 5 is 40. what you really need to watch out for, sometimes one of these guys is negative, right? And then you're going to just say, okay, it's 4 times 2 times negative 5. I'm going to be minus and negative, which is plus, right? Okay, over, and 2 times 2 is?
4.
Okay, so x is equal to 7 plus or minus 49 minus 40 is 9. Over 4, what is the root of 9? So it's 7 plus or minus 3 over 4. And that gives us 2 answers, right? So either x is equal to 7 plus 3 over 4, which is 10 over 4, which is 5 over 2, or x is equal to 7 minus 3 over 4, which is 4 over 4, which is 1. And we're shocked. Really? Wow. Who would, well, they're same answers, right? So if I asked you to solve this quadratic, just algebraically determine, right? That's the instructions. Algebraically determine. What does determine mean? Show your work. Algebraically, I have to use some method that involves, numbers and stuff, right? Like I can't just throw it in my calculator. And you looked at that and you said, I can't figure out how that factors, right? And some of them don't factor, so, and then you did it using the right-hand method. It's going to take a little bit longer, but you're still going to get the same answer, right? X is 5 halves, X is 1. Okay, so whether you factor or use the quadratic formula, you get the same answer. Okay, questions, comments, solutions, problems? Use your graphing calculator to sketch the graph of the equation y equals 2x squared minus 16x plus 35. Based on the graph, okay, so remember, this is like the first unit, right? Y equals, right? Like show me the whole quadratic. Y equals 2x squared. Okay, let's do that. On. Y equals 2x squared minus 16x plus 35. And I'm just going to hit graph. I have no idea what this looks like, so we'll go with the standard window. Say, it looks like that. Based on the graph, does it have any solutions, right? To the equation, x equals 0. Any values of x? 0. What value of x is going to make y equal to 0? Y is the graph, by the way. Come on, we talked about this like 5 minutes ago. Which way does it open? Where's the vertex? Above the axis, right? So will y ever be 0? No. So does it have any solutions? No. No solutions. So it's asking that, right? Does it have any solutions? You can set your window if you want to see more of it, but I don't really need to see more. I can see enough, right? There's the vertex. It opens up. How do I know it opens up besides the graph opens up? Positive a value. This thing opens up. What's the y-intercept? 35. Does it have any solutions? No. Explain why or why not. So why doesn't have any solutions? Because it doesn't. That's always good for marks.
Yes. Yes.
Okay, so how about this? It opens up and its vertex is above the x-axis, so there are no x-intercepts. So the solutions to the roots of the equation are the x-intercepts of the graph, or the zeros of the function. Values of x that make y 0. Use the quadratic formula to show algebraically there is no solution for the equation. So what's it going to look like when we have no solution? Okay, here's quadratic formula. Or sorry, here's the thing. What's a? 2. What's B? Negative 16. What's C?
35.
Yes. Okay, here's the quadratic formula. Okay, so if you're solving a problem, you're going to use the quadratic formula. Write down the quadratic formula. And just see if that's the one we give you. Yeah, that's exactly what we give you on the formula sheet. Right? Looks exactly like that. Okay, so we substitute in, right? X equals negative 16. Always going to put the B value in parentheses, right? Especially if it's negative. That's when, minus 4 times A, which is 2 times 35, which is C times AC. All over. Make sure the all extends. Okay. So, get it in the form ax squared plus bx plus c equals 0, right? So you need to have it. Left side, right side has to be 0. Needs to be in standard form. Identify A, B, and C. Okay, what are they? Just state them. Write down the quadratic formula. Substitute in. What's the negative of negative 16? 16. Plus or minus, what's negative 16 squared? 256. What's 4 times 2 times 35? 8 times 35. 2, 4, 280. 280. 256 minus 280, and 2 times 2 is 4. What's 256 minus 280? Negative 24. Where's the problem here? We have a negative under the root sign, right? We cannot do that. What happens if we try and take the square root of negative 24? Error. No real answer. Okay. So algebraically, what do we say here? Point to here and say, no real solution. What did the graph look like? It's a quadratic that opened up whose vertex was above the x-axis. What else could the graph have looked like if there was no answer? Quadratic that opens down and whose vertex is below the axis, right? Some special notes about the quadratic formula. It can be used to solve any quadratic equation, even if it is not factorable. If the radicand being the number under the root sign, if the radicand is a perfect square, then the solution can be found by factoring. At that point, you're not going to bother factoring, right? Because you've already solved it pretty much. Right? We got to that 7 plus or minus root 9 over 4. At that point, you could have said, oh, this would have factored. But at that point, you might as well just say 7 plus or minus 3 over 4 and just get your 2 solutions. Okay? If the radicand is negative, then the equation has no solutions, no roots. Okay, so if you get a negative under the radical sign, you just stop there. If you've done the test, you want to come back to it a bit later. Go and graph that and just say, well, based on the equation, because the A value is positive, I know this thing's going to open up. I expect to see the graph open up and be above the x-axis. If it's not, then I made a mistake when I was trying to use the formula. Okay, exact values involving radicals. Simplify the following and leave the answer as an exact value. So this is basically, we've used the quadratic formula and we've got a solution. Remember, this would always say plus or minus. We're just working out one solution here. So we get 16, negative 4 squared is 16, minus 4 times 1 times negative 2. Okay, forget the minus. What's 4 times 1 times negative 2? Negative 8. What are you going to write when you go minus negative 8? Plus 8. Okay? So that's what I want you to do on this line, right? So you square that. Remember, this is always positive. You ever write a negative number here, you've done something wrong. Okay? So just catch yourself when you write. So you write down the radical sign and you're doing that. If you write a negative, did it wrong. You punched in your calculator -4 squared and it put out -16. Right? Instead of bracket -4 bracket squared. Yep.
Should it be 4 plus or minus?
Yeah, it's not. That's the question is just right. We're just simplifying, I think. Over 2. 16 plus 8. 24. Over 2. And we got to simplify 24. Okay. Now, simplify means change it to a mixed radical. So what is the square root of 24 expressed as a mixed radical? I'll let you figure this out. You can just state it. You just get to write your answer. So it's going to be something root something.
Why do you have to do it in this method?
You'll see. Yep. Yeah. You weren't about to say 2 root 6. 2 root 6. Why is it 2 root 6? Yeah, so the largest square that goes into 24 is 4, right? 24 is 4 times 6. So here, we have some scratch paper over here. Or we have a scratch board over here. So, root 24. 4 times 6. Root 4 root 6. 2 root 6. So you can do that. It could be on scrap paper. It could be just somewhere scribbled on the side. It could be on the back of a blank piece of paper. But that's what we got right now. Why do we do that? So, what do you notice about 4, 2, and 2? They're all divisible by 2. So we're going to do that. I'm not going to write it over 1. Right, that's what it'll be. So here's what's happening. I'll give you the long version. 4, 2, and 2 all share a common factor of 2. So I'm going to take out a 2 as a common factor. So up top, that's 2 times bracket 2 plus root 6, right? That gives me a 4 plus 2 root 6. On the bottom, I have a 2. The 2's cancel. Like, wow, there's like a replacement. There's still somebody sitting. Okay, and so the answer is, I know, it's amazing, right? So you can turn around and okay, so your answer is 2 plus root 6. That's why we change entire radicals to mixed radicals, because maybe it simplifies, and we have to simplify it, right? And you'll see that. So if this multiple choice question, one of the answers will be 2 plus root 6, and you'll have 4 plus 2 root 6, or actually you'll have 4 plus root 24 over 2, and you'll be looking for it and say, I don't see it anymore. Then you're going to have to say, okay, wait, maybe if I remember that simplifying stuff. Okay, I'm not quite done yet. Okay, -6 plus root 6 squared is 4 minus 2 times 1. 4 times -2. Sorry, it's 4 times -2. -8 times 1. -8 minus -8. What do I write? Plus 8. 2 times -2. -4. Okay. -6 plus 36 plus 8. 44 over -4. We need to simplify root 44. What is it? Something root something. Go ahead. Come on, make a contribution. Yeah. Yes. Good, right? Got some skill. Good to see. Okay.
You all right with 2 root 11? Where'd it come from? 44 is 4 times 11. The root of 4 is 2, right? So it's the root of 4 times 11, which is root 4 root 11, which is 2 root 11. What do you notice about -6, 2, and -4? So what I'm going to do is, I want to get rid of a negative, right? So I'm going to factor out a -2 from the top. I'm just going to say, look, they're all divisible by 2. That makes this +3, right? -2 times 3 gives me -6. That turns this into a negative, and we take out the 2, so it's just a root 11. Okay. Make sure, right? -6 plus 2 root 11. Okay, that's all good. Over -4. What are we going to do with -2 and -4? Cancel them, right? How many times does -2 go into -4? Twice. So what are we left with? 3 minus the root of 11 over 2. Okay, so you will be solving using the quadratic formula. Then you've got to take the entire radical and change it into a mixed radical and simplify if possible, right? It's not always possible. So, maybe we have like a 6 here and a 2 here and a 3 down here. Nothing we can do, right? The common factor needs to go into all of these guys, right? Into this number, this, and there has to be a number here. Or if it's just root 11, you're done. So if I have -6 plus 3 root 11 over -4, I'm done. There's nothing I can do with it, right? Because there's no common factor. Okay. You need to be able to take a common factor out of the top that will go into the bottom. So how much longer does this go? Is this the last one? Or?
No?
No?
There's more.
Wow. How much time do we have? Tons of time. Solve each of the following equations. We've only been at it for 42 minutes. Come on. The sound you just heard was a head hitting the desk. Solve each of the following equations by it's just the way it is sometimes, right? Talk to the junior boys from Notre Dame. They'll tell you all about it. 78 to nothing. And they got to nothing. So. Yeah, so it was 64 nothing at the half, and then. Okay, anyways, solve each of the following equations by the quadratic formula. Write the answers as exact values where possible, and also round to the nearest hundredth. Okay, so we're going to do that sometimes, right? We want exact values, and we also want to the nearest hundredth. So in an application question, you're often going to want nearest hundredth, but in an algebraic type question, in an algebra situation, you'll often want exact values, right? So we're going to do both. So the first step is we need to get it into the form ax squared plus bx plus c, which means we need to expand the right side. We get x squared plus x plus 2. Now we need to move everything over to the left side. So why don't you give that a try? Rearrange it. Move the right side over to the left side. And make sure that the right side is equal to 0. So write your next expression. Might look something like this. Okay? I don't know what's wrong. Maybe I'll occasionally write something down wrong just to see if you're all still with me. Okay, hearing no objections, I guess we should carry on. I don't know, -5. So when I move that x from the right side, I need to subtract it. Brings up a good question, right? Which is like, okay, so I've done the test, I got like 20 minutes. You can check your answer, right? You can solve this graphically. Get answers rounded to the nearest hundredth. You're already going to have answers rounded to the nearest hundredth. You can verify they're the same. If they're not, then you got to start looking. Okay, what's wrong? Okay, what's A? What's B?
let's see. What's the formula? Negative b plus or minus the square. Oh. Okay. You do the substitution. Okay, I've given you a head start, so now I'll start on the substitution. Okay, so there's our substitution. Now, if we just need an answer nearest hundredth, you could actually just do it from here, right? But we don't. We need exact value solution. So we need to keep going. We need to simplify this. Okay. So negative negative 6. Okay. That's the next line. Yes, no? Yes, no? Really? 36 minus 8? Yeah. 36 minus 8? Mm-hmm. Come on, man. Come on, man. Okay, so the root of 28 is the root of 4 times 7, which is root 4 root 7, which is 2 root 7. And then 6, 2, and 4 are all divisible by 2, so I'm just going to divide each of them by 2. 3 plus or minus root 7 over 2. I now need the answers to the nearest hundredth. So, how do I do that? Get out of this. So 3 plus root 7. I'm just going to hit enter, right? That's the top. Let's just work out the top. Okay, divided by 2. 2.82. Let's go 3 minus root 7. Oh, the easy way to do that is just to go back up here, pop over, cut that out. Change that to a minus. Hit enter and divide by 2.18. Okay, there's your 2 answers. Okay, exact value. This is 2 answers, right? There are 2 answers here. Right, the plus or minus does that. Gives you the 2 answers. Right, just that one symbol. Okay, and then when you actually go to evaluate them, you have to go 3 plus root 7. And I would just hit enter there, right? Like work out the top. Or you go bracket 3 plus root 7 bracket divided by 2. If you go 3 plus root 7 divided by 2, like this, 3 plus root 7 divided by 2. Well, first of all, that's not even in the right place. So 3 plus root 7, move over, divided by 2. Your calculator is going to do this first, right? It's an order of operations. I have to divide. It's going to go root 7 divided by 2 and then add 3 to it. And that's not the right answer. Okay? All right? So I would probably just go 3 plus root 7, enter, divided by 2, enter. Right? Easiest way when you're working out quadratics. Okay, let's do this one. Wow. Okay, what do we got? P squared plus 2p minus 3p is minus 1p, minus 6 is 2p squared minus 8p. Okay, so first step is to expand. Then collect. Well, they're all collected. Then move to one side. Now I'm actually going to move to this side. right? And go p squared, right? Going to subtract. You're going to add the p, minus 7p. You're going to add the 6. Okay. So I'm going to the side that has the larger value of p squared, so I end up with a positive a value. Okay. Quadratic formula will work with a negative a value. It's just a pain, right? I don't want to divide by a negative. And what's that equal to? See, everything got moved over. So yeah, equals 0. So although I moved everything to the right side and had a 0 on the left side, and then just switched the sides, right? I mean, they're equal, so it doesn't matter which one you write on which side. He says, waving hands in air, if you're listening to this. Okay. I'm going to use the quadratic formula, so we identify a, b, and c. A is 1, right? If there's no number in front of the x squared or the p squared or whatever, it's a 1. C is 6. Write down the formula. Humming in your head. Pop goes the weasel. Right? Or else, very low. It's okay if somebody walked by and you're all sitting there writing a test. Humming, pop goes the weasel. Okay, so we got negative 7. Negative 7 in quantity squared, right? Remember, there's always going to be a positive. Minus 4 times 1 times 6, all over 2 times 1. Negative 7 is 7. Negative 7 squared is 49. Minus 24 over 2. I thought that factored. I was looking at it saying, this thing factors. And it does, but it's okay, right? Because if you don't see it factors, and it just said algebraically determined, then you just go and solve it. So what's next? X equals 7. Root 25 over 2. Root of 25 is 5. So my two solutions, I got x equals 7 plus 5 over 2, which is 12 over 2, which is 6. And x is equal to 7 minus 5 over 2, which is 2 over 2, which is 1. Okay. Those are exact values, right? Slide that up a smidge. Good, give me a moment. Up that hand. Is there more?
Oh, wait.
Yeah.
Oh, wow. More.
We don't have the.
You don't have that?
No, we have one.
Thank God, eh? Oh, you got this negative 3y squared minus 18 equals 0.
Yeah.
Then you got applications. That will be done by 10:17. Okay. Remember, I'm going to put this up. It'll be up by the end of the day, right? Okay, so you don't have this one, right?
No.
Thank God for small favors. Okay. So what if you have a value that's 0, right? Now we know that a can't be 0 because then it wouldn't be a quadratic. Quadratic, you have to have a value for a, right? There must be an x squared. B can be 0 or c. In this case, b is 0. Okay, so this one should solve pretty quickly. Okay, so we start off writing down the formula. Well, humming pop goes the weasel in our head. And we go negative 0. And we go 0 squared minus 4 times 3 times negative 18 all over 2 times 3. Okay, so I've got 0 plus or minus. So 0 plus or minus just becomes plus or minus, right? Okay, and that just means that when I go to do the solutions, I'm going to have a positive radical and a negative of the radical. Right? I don't need to worry about that negative 0. 0 squared, I'm not worried about that. So minus, I've got 4 times 3 is 12. 12 times 18. 12 times 3. What's that, 216 or something? Yeah, 216. So it's minus negative 216, which is positive 216, over 6. Square root of 216. So it doesn't actually have a square root, right? But we need the largest square. I think, is 36 going in it? I think it goes in 6 times, right? Yeah. Okay, so this is plus or minus 6 root 6 over 6. These guys cancel. And you have plus or minus the root of 6. Okay, again, look, if mixed radicals, you know, if you plug in the root 216 and it's like magic that it became 6 root 6, go to Khan. I haven't ever seen the Khan Academy video, but go to Khan Academy, look at their video on just changing entire to mixed radicals or that, right? They're always short-ish videos, right? Like 5-8 minute videos, so, you know, it's not like you go on YouTube, and if you look up mine on YouTube, it's like another one of these hour-long videos that are, you know, just, oh my God, right? So, check out some short ones. All right, let's go do the application. This is the last one, right? Oh my God. It's so long. You had a work period yesterday, didn't you? It's okay. You can't complain. The result you paid, you know.
Yep, it's also continued tomorrow.
Paying it forward. And this is also continued tomorrow, right? So tomorrow would be like, we could do a couple of examples and then you just have a lot of time to work. Okay, anyway, so store rents video games per month at the, yeah, it's like, right. Where's the last video game rental store you ran into? Where's the last video rental store you ran into? Are there any video rental stores still left in the city? Is it like Casablanca or something still? Or? Yeah. Yeah, exactly, right? I mean, how do you watch movies? You download them.
I don't download. Just stream.
Oh, you stream? I don't like streaming because you know it can get chopped up. I'd rather download them. Okay, anyway, a store rents 700 video games per month at the current rental rate of $4.50 per game. They would like to increase the rental rate so that the revenue will be increased. The owners know that if they can increase the rental rate by $1 per game, they will rent 30 fewer games per month. Can the owners increase the rental rate enough to generate a revenue of $7,000? Okay. So the question becomes, can we model this situation? And can we find out if they can generate a revenue of $7,000 and then what would the price be and blah, blah, blah. So write an equation for revenue as a function of the number of price increases. So we're going to start off with our variable. Right? We've seen these kinds of questions, right? So let X be the number of price increases. And actually, it's $1 price increases, right? When you set these up, and you set up an equation, I want you to just think about it in terms of the problem, right? I mean, the words are pretty clear. And, you know, it's $4.50 a game. If I increase it by $1, it'll be $5.50 a game, right? If I increase it by 2, if I have 2 price increases, it'll be $6.50. So when you go to set up, write an equation for revenue as a function. So the revenue will be the price I'm renting at, which is $4.50 plus X. Right? So if I have 1 price increase, the rental price, if I have no price increases, the rental price will be $4.50. 1 price increase will be 5.5. 2 price increases, 6.5. And that matches that, right? 4.5 plus X. Okay, so I've got the right price. Then I've got the number of games. Well, I was renting 700 games, but what's going to happen to the number of games? Minus 30x, right? So you think if I do one price increase, I'm going to rent how many games? Well, 700 minus 30 is 670. Is this 670? Yeah. If I do two pricing, or let's say I do four price increase, that's 120. 700 minus 120 is, well, that's going to be this, right? This will be 700 minus 120, it'll be like 480 or something, or 580 or 580. Okay, so we have an expression for revenue. Rewrite the equation. Now we want to know, can we make $7,000? So it becomes 7,000 is equal to 4.5 plus x times 700 minus 30x. So that's our new equation, right? Can the revenue be $7,000? Okay, to do this, we need a quadratic equation, right? We know that the right side is going to be a quadratic and multiply it out. So let's multiply it out. I'm going to do all four terms this time. It's not as easy to do the two middle terms in your head. So 4.5 times 7 is 3150 or something? Yeah? Okay, so 3,150. 30 times 4.5, 135? Check it. I'm just doing this in my head, so I don't know.
Yes.
Okay, so minus 135x plus 700x. Okay, don't need a calculator to do that. Minus 30x squared. Okay, wait, and there's 7,000 over here. Okay, so if I want a positive x squared, I'm going to move the negative 30 to x. I'm just going to basically kind of move everything over, right? But before I do that, one more line. So 7,000 equals 3150. I want to collect these two terms, right? So 700 minus 135, right? Which is what, like 600 and then minus 35, 565? Check the math. Okay, so plus 565x minus 30x squared. Okay, so we're moving the right side to the left side. So I'll get a positive 30x squared. Okay, so 30x squared minus 565x, and then 7,000 minus 3150. I didn't want to do that in my head. Was it like 3850 or something?
7,000 minus what?
7,000 minus 3,150.
3,000.
No, it was 3,850. Oh. So that's plus 3,8. Actually, it wasn't as hard as I thought it was. Equals 0. Okay, everybody with me so far? No, it's okay. You can go back through this again, right? So, you know, if this kind of went by you or something, then, you know, tonight go find it on YouTube, scrub it forward to the like 1 hour mark or something. Like, God, how long is this thing? And you can watch this again, right? So just go through it. Any part of the lesson, right? If you missed any part, or if there's a part where you just weren't really sure about what happened, go back and look at it. Then come in and ask in Wise Time. Or come in Wise Time and look at it. Go to the library at Wise Time and look at it. Use your Wise Time wisely. Okay, solve using the quadratic formula. So A is equal to 30, B is equal to negative 565, C is equal to 3,850, and you surely need a calculator to do this, right? Because we're going to be squaring 565 and stuff. So, you know. Formula, x is equal to negative b plus or minus over 2a. Substitute in, so we've got negative 565. I mean, that one I can do in my head. Plus or minus square root of 565 squared, negative 565 in brackets squared, minus 4 times 30 times 3850, all over 2 times 30. Okay, so x equals 565 plus or minus the square root of. So work that out. So I want negative, you don't need to do negative 565 squared, just square 565. So go 565 squared minus 4 times 30 times 3850. Because if this comes out as negative, it means no, we can't. So what do we get? 565 squared minus 4 times 30 times 3850. key to the whole problem. It's this value under the radical sign. If it's negative, then we can't. Just waiting for independent verification here. Come on, man, I can do that faster on the board with calculator. I have to do this myself. Oh, just call out an answer. 565 squared minus 4. How seriously? How can it take you to the handheld device? Negative 142,775. Oh, I got that. Yeah.
I did.
Yeah, sure. Good look, it's in my calculator. I just wouldn't say anything about it. Okay, if it's negative, what does it mean? You can't solve it. What does that mean about the $7,000 revenue? Ain't gonna happen, right? Think of the NHL rep. Can't do that.
So there's no solution.
There's no solution. So you just point here and say, no solution. And then you could write something that says,
That's on next one.
write something that says, can the owners increase? No, the owners cannot generate revenue. The owners can't generate revenue of $7,000.